Welcome. This is question 2 from the Block 1 homework. It pertains to material we covered in Chapter 1 of the course. And we have a lady, she's makes $120,000 this year, and every year her income is expected to rise by 2.5%. And she has about 32 years left of her career. Perhaps she's 35 years old, and she plans to work to her normal Social Security retirement age, which happens to be age 67 if you're born in 1960 or later. And so she's asking us how much insurance would she need that her husband can put into an account that yields 5%. So it seems like they're already telling us they have an account that he could put the life insurance proceeds in that yields 5% per year. And from that account, he'll withdraw 120,000 the first year. Let's say she dies right away. She'd take out $120,000 now. And every year he'd give himself 2.5% more. And there's no mention of a final amount like at age 67 that he needs another $1 million to fund his own retirement. So the future value I'll put in 0. There's no mention of anything like that. That she just wants to replace her income from her working career. So it seems that he has his own retirement plan. We're not going to worry about that. N is 32. She has 32 years left of her working career, and the payment is 120,000. We'll set the calculator payments per year and compound per year as 1. And we're going to set the calculator to begin. Be sure to set the calculator to begin. And it says here in the last sentence, assume each withdrawal will be taken at the beginning of the year, which makes sense. We wouldn't want we wouldn't want her husband to have to wait an entire year after she's gone to get the first payment. We'd want it to be paid right away. Now, remember that we're expecting 2.5% more per year. In other words, he wants to pull out 2.5% more in the second year than he pulled out in the first year, and then all along through the 32-year period. So this is what I got to do to make that happen. I have to use the real interest rate. So open parentheses, 1.05. That's what the savings account that he'd invest the money in, the life insurance proceeds, that's what it's expected to yield, divided by 1.025, that's the expected rate of inflation. Her salary is expected to rise at 2.5% per year, minus 1, times 100. The times 100 converts a decimal into a percentage because that's what the calculator accepts. It doesn't want a decimal, it wants the interest rate as a percentage. When you do that work and you scroll over to the present value, the number that fills in there is going to be just under 2.44%. Be like 2.43 and change. And then you're going to calculate the present value. This is what you're going to solve for, and you'll get $2,709,030.13. So that's the present value. That's the amount of life insurance she needs. If she had that amount of life insurance and she were to die today, her husband would put this amount, this $2.7 million, into an account yielding 5%, and he'd immediately withdraw $120,000. He'd immediately take that out. And then next year, he'd take out 2.5% more, which is something like $123,000. So every year, he'd pull out 2.5% more than the last year. And so this is the amount of life insurance that she needs in order to replicate her salary in her absence, meaning that she died. And so that concludes this little tutorial on question 2 from block 1 of the homework.